According to National Electrical Code Table 310.16, for a 3000 amp 6-volt direct current system, the minimum conductor size for copper conductors is 3000 kcmil. When connecting existing bus bars to a rectifier, multiple conductors can be used to distribute the current evenly and reduce voltage drop. The number of conductors required depends on the size of the conductors used. The reference table 310.16 is located in Article 310, Conductors for General Wiring in the National Electrical Code. A practical recommendation is to use multiple 1500 kcmil copper conductors for the connection. Connect the conductors in parallel to the rectifier terminals and bus bars. It is critical to ensure that the conductors are properly sized and terminated to handle the current and voltage requirements. Always follow all applicable electrical codes and manufacturer's instructions for proper installation and safety. When dealing with high amperage direct current systems, several factors must be considered to ensure a safe and efficient installation. These factors include ampacity, voltage drop, conductor material, insulation type, ambient temperature, and grouping of conductors. Ampacity refers to the current carrying capacity of a conductor. It is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. Table 310.16 in the National Electrical Code provides ampacity ratings for various conductor sizes and insulation types. For a 3000 amp direct current system, you need to select conductors that have a combined ampacity of at least 3000 amps. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, you should use larger conductors or multiple parallel conductors. Conductor material affects both the ampacity and the resistance of a conductor. Copper is a commonly used conductor material due to its high conductivity and relatively low cost. Aluminum is another option, but it has a lower conductivity than copper, so you would need to use a larger size aluminum conductor to carry the same amount of current as a copper conductor. Insulation type affects the temperature rating of a conductor. Different insulation types are rated for different maximum operating temperatures. You should select an insulation type that is appropriate for the ambient temperature and the operating temperature of the conductor. Ambient temperature is the temperature of the surrounding air. The ampacity of a conductor is reduced as the ambient temperature increases. You need to adjust the ampacity rating of a conductor based on the ambient temperature. Grouping of conductors also affects their ampacity. When multiple conductors are bundled together, their ability to dissipate heat is reduced, which lowers their ampacity. You need to apply adjustment factors to the ampacity rating of conductors based on the number of conductors in a raceway or cable. In the specific case of connecting a 3000 amp 6-volt direct current rectifier to existing bus bars, the use of multiple parallel conductors is highly recommended. This approach helps to distribute the current evenly, reduce voltage drop, and improve the overall efficiency of the system. Using multiple smaller conductors instead of one very large conductor also makes the installation easier, as smaller conductors are more flexible and easier to handle. When using multiple parallel conductors, it is important to ensure that all conductors are of the same material, size, and length. This will help to ensure that the current is evenly distributed among the conductors. You should also terminate each conductor properly to ensure a good electrical connection. The termination method should be appropriate for the size and type of conductor being used. In addition to the National Electrical Code, you should also consult the manufacturer's instructions for the rectifier and bus bars. The manufacturer may have specific recommendations for conductor sizing and termination. It is also important to follow all applicable local electrical codes and regulations. These codes may have additional requirements for conductor sizing and installation. Safety is paramount when working with high amperage direct current systems. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not familiar with electrical work, you should hire a qualified electrician to perform the installation. The installation of a 3000 amp 6-volt direct current rectifier requires careful planning and execution. By following the guidelines outlined above, you can ensure a safe and efficient installation. Remember to always consult the National Electrical Code, manufacturer's instructions, and local electrical codes before beginning any electrical work. Understanding the NEC tables is crucial for safe electrical installations. These tables provide essential information on conductor ampacity, conduit fill, and other critical factors. One of the most frequently used tables is Table 310.16, which provides ampacity ratings for insulated conductors rated up to 2000 volts. This table lists the allowable ampacities for various conductor sizes, insulation types, and installation conditions. To use Table 310.16, you need to know the conductor size, insulation type, and ambient temperature. The conductor size is typically expressed in American wire gauge or KC mil. The insulation type is indicated by a letter designation such as THHN, THWN, or XHHW. The ambient temperature is the temperature of the surrounding air. Once you have this information, you can look up the ampacity rating in the table. It is important to note that the ampacity ratings in Table 310.16 are based on specific conditions. If the actual installation conditions differ from these conditions, you may need to adjust the ampacity rating. For example, if the ambient temperature is higher than the temperature listed in the table, you need to derate the ampacity. Similarly, if the conductors are bundled together, you need to apply adjustment factors to account for the reduced heat dissipation. Another important table is Chapter 9, Table 1, which provides information on conduit fill. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The National Electrical Code limits the amount of conduit fill to prevent overheating and damage to the conductors. Chapter 9, Table 1 lists the allowable conduit fill for various types of conduit and conductor combinations. To use this table, you need to know the size and type of conduit, as well as the number and size of conductors. Once you have this information, you can look up the allowable conduit fill in the table. It is important to follow the conduit fill requirements to ensure that the conductors are properly ventilated and protected. The National Electrical Code also contains tables that provide information on voltage drop, grounding, and overcurrent protection. These tables are essential for designing safe and efficient electrical systems. By understanding the NEC tables and how to use them, you can ensure that your electrical installations comply with the National Electrical Code and provide a safe and reliable power supply. When installing electrical systems, it is crucial to understand and apply the concepts of ampacity and derating. Ampacity refers to the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on its size, material, insulation type, and installation conditions. Derating is the process of reducing the ampacity of a conductor to account for factors such as ambient temperature, grouping of conductors, and conduit fill. These factors can cause the conductor to overheat, which can lead to insulation damage, reduced lifespan, and even fire. To determine the appropriate ampacity for a conductor, you should first consult the National Electrical Code Table 310.16. This table provides ampacity ratings for various conductor sizes and insulation types under specific conditions. However, these ratings are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than this, you need to derate the ampacity of the conductor. The National Electrical Code provides adjustment factors for ambient temperature in Table 310.15b2. These factors are used to reduce the ampacity of the conductor based on the difference between the actual ambient temperature and the reference temperature of 30 degrees Celsius. In addition to ambient temperature, the ampacity of a conductor may also need to be derated if the conductors are bundled together or installed in a conduit with other conductors. When multiple conductors are bundled together, they generate more heat, which reduces their ability to dissipate heat. As a result, their ampacity must be derated. The National Electrical Code provides adjustment factors for the number of conductors in a raceway or cable in Table 310.15b3. These factors are used to reduce the ampacity of the conductors based on the number of current carrying conductors in the raceway or cable. It is important to note that the directing factors for ambient temperature and the number of conductors are cumulative. This means that if you need to direct the ampacity for both factors, you should multiply the ampacity by both directing factors. In addition to the National Electrical Code, you should also consult the manufacturer's instructions for the conductors and equipment being installed. The manufacturer may have specific recommendations for ampacity and directing. By understanding the concepts of ampacity and directing, you can ensure that your electrical installations are safe and reliable. Always consult the National Electrical Code and manufacturer's instructions before beginning any electrical work. When working with electrical systems, it is essential to understand the principles of parallel conductors. Paralleling conductors involves connecting two or more conductors together to increase the overall ampacity of the circuit. This technique is often used when the required ampacity exceeds the maximum ampacity of a single conductor. The National Electrical Code allows the use of parallel conductors under certain conditions. Firstly, all parallel conductors must be of the same material, that is copper or aluminum. Secondly, they must be the same size and circular mill area. Thirdly, they must have the same insulation type. Fourthly, they must be terminated in the same manner. And fifthly, the conductors must have the same length. When paralleling conductors, it is important to ensure that the current is evenly distributed among the conductors. This can be achieved by using conductors of the same length and ensuring that the terminations are properly made. If the current is not evenly distributed, one conductor may carry more current than the others, which can lead to overheating and failure. The National Electrical Code requires that parallel conductors be sized no smaller than 1/0 American wire gauge. This requirement is intended to ensure that the conductors have sufficient mechanical strength and ampacity. When calculating the ampacity of parallel conductors, you can simply add the ampacities of the individual conductors. For example, if you have two 1/0 American wire gauge copper conductors with an ampacity of 150 amps each, the total ampacity of the parallel conductors would be 300 amps. It is important to note that the ampacity of parallel conductors must be directed if they are installed in a conduit with other conductors. The National Electrical Code provides adjustment factors for the number of conductors in a raceway or cable in Table 310.15b3. These factors are used to reduce the ampacity of the conductors based on the number of current carrying conductors in the raceway or cable. In addition to increasing the ampacity of a circuit, paralleling conductors can also reduce voltage drop. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. By using parallel conductors, you can reduce the resistance of the circuit, which will reduce the voltage drop. When installing parallel conductors, it is important to follow all applicable electrical codes and manufacturer's instructions. Always disconnect the power before working on any electrical equipment. If you are not familiar with electrical work, you should hire a qualified electrician to perform the installation. By understanding the principles of parallel conductors, you can design and install electrical systems that are safe, reliable, and efficient. Always consult the National Electrical Code and manufacturer's instructions before beginning any electrical work. Ensuring proper termination techniques for conductors is crucial for safe and reliable electrical connections. Improper terminations can lead to overheating, voltage drop, and even fires. There are several different types of terminations available, each with its own advantages and disadvantages. Some common types of terminations include compression connectors, set screw connectors, and bolted connections. Compression connectors are crimped onto the conductor using a special tool. These connectors provide a reliable and gas-tight connection. Set screw connectors use a set screw to secure the conductor to the connector. These connectors are easy to install, but they may not provide as reliable a connection as compression connectors. Bolted connections use bolts and nuts to secure the conductor to the connector. These connections are often used for high current applications. When selecting a termination method, it is important to consider the size and type of conductor, the current rating of the circuit, and the environmental conditions. The termination method should be appropriate for the size and type of conductor being used. The current rating of the termination should be equal to or greater than the current rating of the circuit. The termination should be suitable for the environmental conditions such as temperature, humidity, and vibration. Before making any terminations, it is important to prepare the conductor properly. This typically involves stripping the insulation from the conductor and cleaning the conductor with a wire brush. The amount of insulation that needs to be stripped depends on the type of termination being used. It is important to follow the manufacturer's instructions for the specific termination being used. When making terminations, it is important to ensure that the conductor is properly seated in the connector. The connector should be tightened to the manufacturer's specified torque. Over-tightening can damage the connector or the conductor, while under-tightening can result in a loose connection. After making the terminations, it is important to inspect them to ensure that they are properly made. Check for loose connections, damaged insulation, and other signs of problems. If you find any problems, correct them immediately. It is also important to label the terminations properly. This will help to identify the conductors and make it easier to troubleshoot the circuit in the future. By following proper termination techniques, you can ensure that your electrical connections are safe, reliable, and efficient. Always consult the National Electrical Code and manufacturer's instructions before making any terminations. When working with electrical systems, safety should always be the top priority. Electrical hazards can cause serious injuries or even death. It is important to be aware of the potential hazards and take steps to protect yourself and others. One of the most common electrical hazards is electric shock. Electric shock occurs when a person comes into contact with an energized conductor. The severity of the shock depends on the voltage, current, and duration of the contact. Electric shock can cause burns, muscle contractions, and even cardiac arrest. To prevent electric shock, it is important to avoid contact with energized conductors. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as gloves and eye protection. Another common electrical hazard is arc flash. Arc flash is a dangerous condition that can occur when a short circuit occurs in electrical equipment. The arc flash can generate intense heat and light, which can cause severe burns and other injuries. To prevent arc flash, it is important to wear appropriate personal protective equipment, such as arc-rated clothing and face shields. It is also important to follow safe work practices, such as maintaining a safe distance from energized equipment. Overloading circuits is another common electrical hazard. Overloading a circuit can cause the wires to overheat, which can lead to a fire. To prevent overloading circuits, it is important to use the correct size conductors and overcurrent protection devices. Do not plug too many appliances into a single circuit. Grounding is an important safety measure that helps to protect against electric shock. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. Make sure that all electrical equipment is properly grounded. Inspect electrical equipment regularly for damage. Damaged equipment can be a safety hazard. Replace any damaged equipment immediately. If you are not familiar with electrical work, do not attempt to perform any electrical repairs. Hire a qualified electrician to perform the work. By following these safety guidelines, you can reduce the risk of electrical hazards and create a safe working environment. Always be aware of the potential hazards and take steps to protect yourself and others. Remember to always consult the National Electrical Code, manufacturer's instructions, and local electrical codes before beginning any electrical work.